I'd like to welcome everybody to our semi-annual Senior Project Showcase.
My name is 𝙂𝙀𝘼𝘈𝘼𝘈 and I am representing Team Arts today. The arm is able to pick up an object from a predetermined location and bring that object back. This isn't remote control, this is programmable, repeatable, and customizable motion. Looking ahead, we hope that our progress on this project can lead to tablet or voice-based commands for the robot, so the robot can traverse a lab environment like a true robotic dog lab assistant.
My name's 𝙂𝙀𝘼𝘈𝘼𝘈. I'm graduating in a week, and I'm a CS major. Our project this semester was working with the robot dog you might see around campus. They bought an arm for the dog, and they attached it to the top of it. We were tasked with controlling that arm and coding it to make it functional. We went through a lot of trials and tribulations to try to get here. The project was 12 weeks, and for 10 weeks we just spent researching, going through documentation, trying things out, going one step forward and 2 steps back. Seth said that earlier. It was great. We eventually got to control the arm, and we were able to complete our project. The robot dog is functioning as we hope. It feels great to be done. A great way to end off the year.
My name is Robert Fanzuti. I'm also graduating in a week, class of 2025, CS honors major. The coding part of this project, it was a long process. There were multiple times where a few of us were in here for multiple hours and we made virtually no progress. I've experienced roadblocks before in code. I've never sat down for 4 hours, gotten up and said, I don't think I accomplished anything. In the end, it actually bared fruit. We were able to move the arm pretty consistently here today, picking up an object, placing it down in the same place, and that definitely opens up the door for putting it on a table, handing it to a person, and then also incorporating the other parts of the robot like the LiDAR and moving around and actually becoming a fully functional robot lab assistant.
My name is Seth Wolfinger. I am also a computer science major, graduating spring 2025. My favorite part of the project was, as much as we didn't make progress on the simulation side, working with the virtual simulators like NVIDIA Omniverse was really fun. Even if the collision detection on the simulators would sometimes make the dog freak out and flip. I have a couple of funny videos on that. So as much as it didn't really help towards our project, it was really fun.
It's stressful. I have been sweating profusely nonstop. I'm not going to show you, but I have. It has been stressful. I'm so glad we have something to show for it. Our team really worked really hard on it. So to be able to have something to show these judges was awesome. It was a great experience. I didn't expect the judges to be as technical as they were. They were really interested in the actual code we were writing, like coding each angle of the joints. So that was really cool. It was a great experience overall.
The first part of our project, after taking over from another student, was to reconfigure some compatibility errors and pivot the project to focus on robots rather than satellites. This project was originally part of a NASA grant, which is why we had to do that pivot. We utilized and trained a new AI model of up to 1,000 images to correctly utilize object recognition and display that in our augmented reality space using the Microsoft HoloLens device. For anyone coming into the robotics lab looking to be trained on any kind of robot. We laid the foundation on one robot so far, and in the future, other students can add as many robots in the lab, if not all of them, as well as other objects to be recognized utilizing our AI.
Hi, my name is Omar. I'm a computer science major, and I'm part of team Ctrl+Alt+Elite. We're presenting our HoloLens project today. The idea behind this project is to be used as a training tool for the CCSU Robotics Lab. Anyone new that's coming in as a visitor, anyone who needs onboarding can put on the HoloLens, which is an augmented reality device, and we create an immersive and interactive environment for them in our Unity engine for them to interact with the robots in the lab and learn about all the different parts of it.
My name is Nathaniel. My major is computer science, and I'm going to talk about some of the challenges we overcame. The first 2/3 of this project, we had a completely broken project. We had to work tirelessly trying to fix bugs and errors to even get it to run. So we didn't even really know what the project looked like on the end point until maybe 4 weeks ago. And then once we got it running, we were able to shift the project, because it was initially about satellites. We shifted it towards robots, and we were able to add a lot more interactive UI that's able to display a lot more information about all the specific parts.
Hi, my name is 𝙂𝙀𝘼𝙈𝙈𝙎. I'm a computer science major as well. And what I will talk about is what worked well for us was pair programming and a group programming. So for the first 3 or 4 sprints, we as a team worked together. We didn't split anything off, and we tried to solve the compatibility issues. And after we got the project running, we split up into 2 teams, one Omar and Nathaniel, one is me and 𝙂𝙀𝘀𝘼𝙈. So we focused on the AI part and they focused on the Unity part.
I'm 𝙂𝙀𝘀𝘼𝙈, and I'm a CS major, and I'll be graduating this May. I'll be talking about one of the most important part of our project, which was the AI model. This AI model, we trained it ourselves. We extensively trained it using 1,000 images, all annotated by ourselves, and which is like doing the object detection for the image that we are using of the robot.
This has been a really rewarding experience. We've been working really hard on this project for months now. It was really awesome to get all of the feedback. It's really nice to get all the praise too for all of our hard work. And it's a good feeling to be able to show off everything we've been doing.
I felt very well with them because we have an AR set that's hard to use. So we actually had to show them how to use it, what to do in the project. That took us some time, but they were very proficient with it. So everyone tried it, at least most of them tried it, and they got to see it firsthand. So we didn't have to show it as we are using it. They used it themselves. So that was pretty good. And I didn't even realize that it's been 1.5 hours. It felt like 5 minutes, to be honest.
I think this is really a good learning experience for us to talk with like different personalities from all around the industry, tech industry. It was really good to hear their thoughts, their feedback on the project, and I think we got a lot of positive feedback on our project, and we are really happy with it.
We feel lucky to work with a device like the HoloLens. Not a lot of people have access to it, and augmented reality is such a new technology. So the fact that we got the opportunity to work with it for a whole semester and create an impressive project that can be used for future training, and anyone that comes to visit the robotics lab can eventually use it, put it on, try out our project. So yeah, it was really rewarding.
I want to thank Dr. Wang, Ryan Sarp, and Dr. Kurkowski, and finally my team. It was a really fun to work with these guys, and then I believe we were successful at the end with everything. Thank you.
Project is about retrieval augmented generation. This is a locally running AI system that takes these documents and finds out the pieces of information that are relevant and then generates an answer.
Hello, my name is Hasro. I'm a computer science major, senior, graduating, and this project here is about retrieval augmented generation. In essence, it allows a local language model to retrieve information from a database. Imagine an educated person with a library. You put new books in a library, it can then refer to those books and answer your questions. It only refers to those books, does not answer anything that's not in those books. It's a local model, which means it will operate without connection to the internet. Proprietary information certainly can be in there, it's on your system and protected. Challenges, just time, there's so much to do and so little time. Future, much improvements to the system can be done. Right now it uses a vector database. The next step is to go to a graph database. And right now it uses chain of thought with DeepSeek R1. But chain of draft apparently is a better method, gives you some improved outcomes. That would be the next step. Altogether, it was a fun project. I was able to definitely explain to my heart's content what this project does and also what the context was, why this project even came to be. It was documentation and knowledge capture that is necessary before transfer of knowledge at the beginning of every semester to a new group of students who then, from scratch, need to get to know this particular robot, this particular project. And this is in that context, developed in that context.
How's it going, everybody? I'm Jay, and I'm with Team P3M. Our project is LLM documentation. Every year, students who are the most experienced from research labs leave their labs and take all the knowledge they gained along with them. Incoming students are forced to start from scratch. Why? Because documenting the work they did is time-consuming and tedious. And let's be honest, who enjoys writing documentation? Instead, it's much more intuitive and quicker for researchers to record a video tutorial outlining exactly what they've accomplished and how they've completed tasks. Our project, LLM Documentation, is able to turn a video tutorial into clear documentation. We've removed features from a previous system that were over-relying on AI, and we've increased the speed of the system from 10 minutes to 3 minutes, as well as decreasing cost from $3 per video to just 30 cents per video. The problem of turnover of members doesn't only occur in research labs, it also occurs in the workplace. We're confident this technology can revolutionize how companies are able to capture knowledge and transfer it.
Good morning, everybody. My name is Nick. I'm from Team Software Modeling Nexus Specialist. The CCSU Robotics Lab has many different robots with many different manufacturers, all with different ways of controlling them. What if there was one unified API that we could use to control any robot in the CCSU lab? This would save time, improve efficiency, and ultimately create a better experience for our CCSU independent researchers. We've utilized ROS and 𝙂𝙀𝘼𝙈 for this project in order to make it as dynamic as possible to fit all of the robots in the robotics lab. And we've provided a demo utilizing the 𝙂𝙀𝘼𝙈𝙍 robot arm.
Hi everyone, how's it going? My name is 𝙂𝙊𝘼𝑉𝙊𝘼𝑍 and I'm representing Team DXperts today. Airfoil production is traditionally done by hand, which is slow and prone to human error. Now imagine if there was a fully autonomous method to address this problem. With our proof of concept, we have successfully captured 4 base edge scans, all from a single button click.